Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday Night Math Night. Thank you, Dr. A, for that incredible introduction. Happy Wednesday. I'm super glad to be back. Priya was with us last week. She did an amazing job. She's another one of our math specialists here. And I'm so lucky to have her as a partner with us. So she works extremely well with me, and I just love working with her as a math specialist. So thank you, Priya, for covering me last week. Before we get started, let's do a quick introduction. I always like to get to know who's in the room, and it helps me guide our conversation. Even though the questions are preset, I like to know who's in the room and what test you're prepping for so that it allows me to kind of guide those rabbit trail conversations that we have throughout the night. So in the comment section, let me know where you're from, what test you're prepping for, and are you a coffee drinker or a tea drinker or neither? My shirt says I run on coffee and Christmas cheer, except I'm not really a coffee drinker. I'm like a decaf coffee drinker. So I don't do caffeine. So where are you from? What test are you prepping for? And are you a coffee, a tea, or none of those drinkers? So without further ado, we're going to go ahead and get started. As we work through these problems, I want you to comment in the comment box if you don't understand what I'm doing, because this session is for you. It's not for me, it's for you. So let me know if you're confused on anything that I'm doing, or let me know if there's something that you want me to go over in the coming weeks. I already have a few things on my list that we're going to go over in the upcoming weeks, like converging and diverging series. We still haven't gone over that yet. Some more apothem problems. So we're definitely going to go over those next week. But let me know in the comments if you have anything else that you want to see me go over. Hi, Joseph. You are a tea drinker but prefer hot chocolate. Oh, I dumped hot chocolate all over my desk today. Hi, Milagros. thank you so much. Yes, I did just get a new job. I appreciate the congratulations. You will be able to be a teacher. I promise. Like, put your mind to it, put your heart to it. Those kids need teachers like us. So, and just like you. And you're a coffee drinker, and I will see you Saturday. So let's go ahead and get started with our first problem. So problem number 1, this is an interesting problem. The figure below shows the route of Sonia's trip from her house to the zoo. Sonia travels 20 miles from A to B, 18 miles from B to C, 4 miles from C to D. So before I read the question, I'm going to go ahead and look at what we're talking about. So Sonia's house is A, and she travels 20 miles, then 18 miles, and then 4 miles to finally land at the zoo. What is the question? If she were able to travel from A to D, much shorter in miles would the trip be? So we want to go from A to D. So we're going to go like up. That. So if she were able to travel from A to D directly, how much shorter would the trip be? So the first thing we need to do is figure out how long the trip is from A to B to C to D. So let's go ahead and figure that out. AB plus BC plus CD. In order to figure out how much shorter, and this is a question everybody struggles with, from kindergarten through adults. The how many more, how many fewer, how much shorter, how much longer is always a confusing question. When we see how much shorter, I'm wondering what that gap is. So I'm going to be solving a subtraction problem because I need to know how much I'm traveling, and then I need to subtract the new distance and figure out how much shorter it is. So I need to find my original, and then I need to subtract the new distance to figure out how much shorter. So that said, AB is 20, BC is 18, and CD is 4. So 20 plus 18 is 38. 38 plus 4 is 42. So that's the original distance. But now I have to figure out the new distance, the distance from point A to point D. So I'm going to be honest with you and tell you what my original thought process was when I saw this. I know I'm probably going to be doing with something with the Pythagorean theorem. A squared plus B squared equals C squared. Because, and I apologize for the cough. I've got like a serious congestion going on. So I apologize if I'm coughing and drinking a lot tonight. It's those new school germs that we all know about. So A squared plus B squared equals C squared. I know I'm dealing with A squared plus B squared equals C squared because I know that I just created some right triangles. And I'm trying to find this distance of X and Y so I can add them together. So the first thing I thought to do was to try to figure out this distance right here separate from this pink distance right here. However, the problem is I don't know what the separation is for 18. I don't know what this distance is versus this distance. I don't know if this is 5 and this is 13. I don't know if this is 6 and this is 12. And without doing a lot of extra work, I really can't figure that out. And I'm certainly not going to ballpark it. Now, here's a secret. If you are stuck and you have no idea where to go, you could always ballpark it. You could make up numbers. So let's pretend this is 5, which would then make this 13. And if I were to do that, I could then find this distance and at least get a ballpark of what I'm working with, because none of these answers are super close to each other. So if that's all you know to do and you have a multiple choice question, that's a test taking strategy. Just do it and see what you get. And you're not probably going to get a number that's exactly that answer, but at least you can pick a number that's close. Now, here's what we would actually do. This actually took me a minute to think about. So here's what I'm going to do. I'm going to create a larger triangle. I'm going to drop this down. And I'm going to extend this out. Joseph, you're absolutely correct. However, I was just giving an example if people didn't know that. So I'm going to extend this figure in both ways. And now I've created this extra large triangle. And now with that, I'm going to highlight it so we can all see it, this triangle right here. Now I can do a squared plus b squared equals c squared with my new dimensions. So how long is this side right here? We already know the answer to that. That is 18 all day. What is the distance from here to here? That's 4, because I've created a rectangle here, and all I did was take this measurement and drop it down here. So I have 4 there, which means, and this is where people are going to make their mistake, they're going to do a squared plus b squared equals c squared with 18 and 20 or 18 and 4. But we have to remember to add that 20 and that 4 together. So this whole side equals 24. So my triangle is 18 and 24, and I can now find x. So that said, I know that x is going to be my c value because it's across from the 90-degree angle. C is always going to be across from the 90-degree angle. So we have a squared, which is 24, plus b squared, which is 18, equals c squared, which is x. Now, what if you did 18 squared plus 24 squared? It would still work because addition is commutative, which means I can add in any order. And everybody needs to know that, elementary through high school. You need to know those properties. So addition is commutative, which means I can add in any order. So now I'm going to use my handy dandy calculator, and I'm going to do 24 times 24, which is 576, plus 18 times 18, which is 324, equals c squared. I'm going to add those things together, and I get 900 equals c squared. Now, what is the square root of 900? Now, if you don't know that off the top of your head, you should know what the square root of 9 is. And that can help us. If you have more than a 4-function calculator, you can go ahead and use that square root button and figure out very quickly what the answer is. But if you don't have a square root button, I know that the square root of 9 is 3 because 3 times 3 is 9. So I can use my 4-function calculator to test. 3 times 3 is 9. 30 times 30 is 900. So I know that x, or c, equals 30. That is not my answer. And that's going to be the most common mistake people make. They're going to go through all that work and they're going to choose 30, but they didn't answer the question. How much shorter? Which is why I always like to do something like this on my paper or on my whiteboard or whatever I'm given when I test, because it allows me to remember that I'm not done yet. My new distance is 30, so now I subtract those and I get 12. So B is the right answer. This problem has Pythagorean theorem. Yes, absolutely. All right, let's move on to problem 2. The length, width, and height of a rectangular prism box Y, respectively, are 2, 5, and 6. A similar rectangular prism box Z has a length, width, and height of 6, 15, and 18, respectively. The volume of prism box Z is how many times the volume of prism box Y. So I'm going to draw both of these rectangular prism boxes so I can see it. So I have Y, and I'm going to draw my box. Two, 5, and 6. And then I have Z. And it is 6, 15, and 18. What do you notice about the relationships between those sides? Because it said respectively, I made sure to put the 2, 5, and 6 in the same respective spot as the 6, 15, and 18. So the 2 and the 6 kind of match. The 5 and the 15 kind of match. And the 6 and the 18 kind of match. What do you notice about that relationship? Yeah, if I do 2 times 3, 5 times 3, 6 times 3, then I get 6, 15, and 18 respectively. So the linear distance is 3 times bigger. However, the cubic measurement is not going to be 3 times bigger. They wanted us to compare the volumes. So I'm going to find the volumes because we were given numbers. Now, if we were given variables, that would be a whole nother story and you would need to commit this to memory. But because we were not given variables, we were given numbers, we can solve this. So volume of a rectangular prism equals length times width times height. That only works for a rectangular prism. We talked about this 2 weeks ago. Volume of a normal prism, any other prism, is going to be area of your base times your height. But a rectangular prism has a rectangle base, and so the area of the base is length times width. So I'm going to do volume equals 2 times 5 times 6, which is going to equal 60. Then I'm going to come over here and do volume equals 6 times 15 times 18. I'm going to need my handy dandy calculator for that one. And that equals 1,620. Now, if I was trying to figure out how many times bigger that is, I can divide this number by this number to figure it out. So 1620 divided by 60 equals 27. The volume of box Z is 27 times bigger than the volume of box Y. Now, you're probably looking at me like, why? Why is that the case, Amy? Here's why. Because a linear measurement is totally different than a square measurement than a cubic measurement. So when we think about linear measurements, linear is perimeter. Square is area. And cubic is volume. So if I'm thinking about how many times something is, if I know how many times something is bigger than something in the linear form, then the area form, I'm going to square that number. And in the volume form, I'm going to cube that number. So because I multiplied my linear distance times 3, I know that I'm looking for the cubic relationship. So I can take that 3 and cube it, which means do 3 times 3 times 3, which is equal to 27 as well. So if, let's look at a problem like this, and this is totally like ad-libbing. If they said, I have box Z and box A, and box Z has side lengths that are 2 times the length of box A. How many times larger is the volume of box Z than box A? In this case, they did not give us numbers, and this is where I was trying to get at. In this case, they did not give us numbers. And because of that, we can't solve it the way we did in the first one, unless we wanted to make up numbers. And let me tell you, if you've been around me long enough, you know I love to make up numbers for problems like this because it helps me visualize it better. So there's 2 ways we can solve this problem. If you have the scaling ratio committed to memory, then you know that the linear relationship is 2 times. So the cubic or the volume relationship is going to be 2 to the 3rd power, which is 8 times. But if you weren't confident in that, you could absolutely create your own boxes. If this is box Z, you could create numbers. And I know it's 2 times, so I'm going to pick even numbers. 8, 10, 12. And they tell us that box Z is 2 times box A, so that would make this 4, 5, and 6. I could find the volumes of those and then compare them. It just takes a little bit longer if you don't know the scale ratios for that. However, I will often create numbers for problems like this just so I can visualize it. So I hope that all makes sense. Let's go ahead and move on to the next problem. Which of the following formulas shows the volume of the image below solved for the height of the prism if H is the height of the base and capital H is the height of the prism? So in this situation, I can actually eliminate 2 answer choices right away. I can eliminate A and I can eliminate B right off the bat. How come I can eliminate A and B right off the bat? Because the question asked, which of the following formulas shows the volume solved for the height of the prism. Both of these are solved for the volume of the prism. Because it's V equals, we're looking at the formula solved for volume. But we want the formula solved for height of the prism. And they defined that H is the height of the prism and lowercase h is the height of the base. Two different things. Well, what do I know about the volume formula for this prism? I know that volume equals area of the base times the height of the prism. I need you to remember that height of the prism is not how tall the prism is, but the distance between the two bases. So height of the prism is the distance between the two bases. So in this case, this is going to be a triangular prism because I have two identical triangle bases where this would be, and I need to label it correctly, this would be the height of the prism and this would be the height of the base. So let's take our volume formula and apply what we know about triangles to solve this. So volume equals, what is the area of a triangle? The area of a triangle is 1/2 base times height times height of my prism. Does that make sense? But now I need to solve it for height of my prism. So I need to get the h by itself. What am I going to do? Well, all of this is being multiplied. So I'm going to divide by the things that I don't want next to that h. So looking at these two answer choices, I can immediately see that my answer is going to be letter C because it is the only answer choice that has division as an option. Now, let's take a look why. I'm going to divide both sides by BH because whatever I do to one side, I have to do to another, and it keeps it equal. So I'm left with V divided by BH equals 1/2 times big H. How do I undo being multiplied by a half? In fact, how do I undo being multiplied by a fraction in general? I multiply by the reciprocal. So if I'm being multiplied by 1/2, if I multiply it by 2/1, it's going to cancel that fraction out and leave h by itself. But what if it was like V divided by BH equals 2/3 capital H, which it's not, but what if? Then I would multiply it by the reciprocal, 3/2, because these cancel and these cancel, leaving h by itself. So I'm going to go ahead and erase this because it has nothing to do with our problem. I just wanted to rabbit trail that for us all. So I'm going to multiply both sides by 2/1. Which leaves me with 2V divided by BH, which is C. All right. Problem number 4. A circle is drawn on a coordinate plane. The circle has a diameter that intersects the circle at points A and B, which are at 7, -4, and 9, 6, respectively. Which of the following represents the equation of this circle? So whenever we're talking about geometry, I'm always, always, always going to draw a picture. So I'm going to draw a coordinate plane, and I'm going to plot these points. Over 9, up 6. And I am not going to be exact with it. I'm just trying to get an image of what this looks like. And over 7, down -4. And what were we told about that line right there? That line is a diameter that intersects at points A and B, which means I'm going to have a circle that looks something like this. And it goes right off our screen, so we're just going to keep it like that. What do we know? And let's go over some circle vocabulary. What do we know about a diameter? A diameter goes through the center of the circle and has endpoints on the circle. We can also think of a diameter as 2 radius. Now, even though they didn't talk about radius, we're going to need it. So what is the radius? It's the distance from the center to the outside of the circle. So a diameter is 2 radius, because if this is the center of my circle, I have a radius there and I have a radius there. What is the equation of a circle? The equation of a circle is x minus h squared plus y minus k squared equals r squared, where h comma k is our center and r is our radius. Now, what do you notice about that formula? The formula has subtraction symbols in it, which means if my center is positive, it's actually going to be negative in the formula. But if my center is negative, it's actually going to be positive in the formula, because a negative and a negative make a positive. So how am I going to figure this out? I have to figure out what the center of the circle is, and I have to figure out what the radius is, or what that distance is. So how am I going to do that? Well, I'm going to have to use my midpoint formula, and I'm going to have to use my distance formula. So I just duplicated this page because I ran out of room, but I wanted to keep all those notes. So how do I find, we're just going to erase all of that. How do I find the center of this circle? I have to do the midpoint, because the center is going to be exactly in the middle of this diameter. So the midpoint formula is going to be x plus x divided by 2, comma y plus y divided by 2. All it is the average. So I'm going to take my 2 x's and divide it by 2, and then I'm going to take my 2 y's and divide it by 2. So 7 plus 9 divided by 2, which I got from here and here, comma, -4 plus 6 divided by 2. Because I did this point first for the x, I'm going to do that point first for the y. 7 plus 9 is 16 divided by 2, which is going to give me 8. And -4 plus 6 is +2, and +2 divided by 2 is 1. So I know that my center is 8, 1, which means I don't even have to find my radius. Why? because my radius doesn't matter because my center is 8, 1. And when I look at my answer choices, this is where test taking strategies really come in handy. I know that my formula is going to be x minus 8 plus y minus, because that's the formula, and then I plug this in, 1, and there's only one answer choice that works, x minus 8 and y minus 1. Now, if there were two x minus 8 and y minus 1s, then I would have to do the distance formula to figure that out. So I'm going to do the distance formula between my center and one of my points. I am not going to do the distance formula between my two diameter points because then I'm going to have to do one extra step. And that one extra step is going to be dividing by 2. And I just don't want to give myself any extra steps. Could you do it that way? Absolutely. Is anyone going to frown upon you? No, because no one's watching you take the test. But I'm going to use 8, 1 and point A just to figure out that radius distance, and then I'm going to solve. I'm not going to do that right now because I want to get through a couple of more problems, but the distance formula is the square root of x minus x squared plus y minus y squared, and you can solve for that distance to figure it out and then figure out what that radius squared would be. All right, let's move on to the next problem. This is a really straightforward problem. This is going to be something that you could see on elementary through high school. It's a very straightforward problem, and if you don't know your properties, this is going to be a very difficult problem. If you know your properties, then you can go ahead, pick an answer, and move on. Test taking secret. If you don't know your properties and you see this problem and you look at the answer choices, please, please, please do not spend 2.5 minutes laboring over this problem, because there's no amount of you staring at this problem that's going to magically fuse that knowledge into your brain. Now, if you remember studying this, take your time. But if this is something where you're like, oh, I have no idea. If you don't know what the definition of commutative property of addition is, choose an answer and move on. Now, if you don't know what that definition is, you're in hot water. You need to know what the definition of the commutative property, the associative property, the identity properties, and the distributive property. Elementary people, you really need to know more how they behave. Middle school and high school people, GK Praxis Core, you need to know how these properties behave and also how to apply them. So, commutative property says I can add my addends in any order. So when I look at these answer choices, adding my addends in any order is definitely not D. D is going to be the identity property because I started with A and I ended with A. I added nothing to it. Which of these answer choices shows being able to add in any order? The one people mostly get mixed up with is commutative and associative. So what's happening is C is going to be the right answer because this is commutative property. Commutative property allows me to add in any order. So A plus B plus C, C plus B plus A. However, letter B is not showing that. Letter B is showing the ability to move my parentheses and add 2 addends first and then the third, or add a different 2 addends first and then the third. So this is actually going to be the associative property. Those are the two that most people confuse the majority of the time. And then letter A is the distributive property because we are distributing the A all the way through. And A is being multiplied by the B, and A is being multiplied times the C. All right, let's move on to the next problem. A cake company is building a cake structure for an event. They need to create a cake in the shape of a triangular prism, which we can see that below because this is absolutely a triangular prism. In fact, it's the same triangular prism we were looking at earlier. The cake must be divided into 3 equal sections that will be different flavors. If the entire cake has the dimensions below, what is the volume of one of the sections? So if I'm going to divide this cake into 3 equal sections, I could divide it here and here. And now I have the vanilla section. I have the blueberry cake section. And I have the strawberry cake section. So the easiest way to figure out the volume of these 3 sections is to find the volume of the entire thing and divide it by 3, or dividing this value by 3 and then finding the volume. Because when I look at this image, if I divide this by 3, then the distance or the height of each of these mini prisms would be 8, 8, and 8. And I could still find the area of my base because my base did not change. So if I find the area of my base, which is the triangle, we did not change the shape of that triangle. We just truncated that volume. So because we didn't change the shape of that triangle, I can just change the height of my prism in my volume formula. So my volume formula is area of base times height of my prism. And area of a triangle, remember, is 1/2 base times height. So if I find the area of this triangle, I can then quickly find the volume of this prism. So volume equals 1/2 base times height of my triangle times the height of my prism. I'm going to use 8 as the height of my prism. That way I don't have to divide. So volume equals 1/2. What's the base of my triangle? 18. What's the height of my triangle? 21. And then multiply that times the height, which I'm going to use 8 because I'm just going to find the volume of that vanilla section. So now I'm going to use my calculator. 1/2 of 18 is 9 times 21 times 8. So 9 times 21 equals 189, and 189 times 8 equals 1,512, which is A. All right, we have time for one more problem before I turn it back over to Dr. A because he did say he has a special surprise for those of you who are still here. So let's go ahead and do this one. Now, this one I do not have answer choices for it. Some assessments have fill in the blanks. And so we're pretending this is one of those. However, even if your test does not have any fill in the blanks, which most of the FDOE tests do not, that does not mean this kind of problem couldn't be on your test. You could just have answer choices for it. This is most definitely a middle school, high school problem. However, everyone needs to know how to find area. What is the area of the shaded figure below? Now, I copy and pasted this image, so we're only looking at this blue shade, not this like weird gray. The weird gray is not part of this problem. So when I look at this problem, I'm looking for the area of the blue. If I were to extend this shape out, I would know that this is creating a square because I have a circle in the middle of it, and a circle has the same diameter no matter what you're doing. So I know that the outside of my square has measurements of 6. When I'm solving this problem, I'm going to need to find the entire area of the square. I'm going to need to subtract out the circle and subtract out these corners. So let's find the area of the square first. Area of the square equals 6 times 6, which is just length times width. So the area of my square is going to be 36. Now, I need to subtract out my circle. So how do I find the area of a circle? Area of a circle equals pi r squared, where r is my radius. So 3.14, if your test defines that as pi, otherwise you leave it as pi, times radius. That's where people are going to get a little tripped up. Actually, I am incorrect. The area of our square is not 6 times 6. The area of our square is 12 times 12 because they defined the radius. They did not say this entire thing is 6. They said only half of it is 6, which means the other half is 6 as well, which makes each side 12. Now I know my radius is 6. So 6 squared is 36. So 3.14 times 36. Let's go ahead and do that. 3.14 times 36 equals 113.04. So I'm going to do 144 minus 113.04. And that's going to equal 30.96. That's what's left. However, that's what's left if these pieces were completely colored in. But they're not. They have these little quarter circles taken out. And those quarter circles, if I add them all together, 1, 2, 3, 4, create a whole circle. So if I create a whole circle with all those little quarter pieces, I can find the area of that and just subtract that out. So my area of my little circle is going to be pi r squared as well. And they defined r for us up here. They showed us that r is 2. So 3.14 times 2 squared, which is 3.14 times 4. So 3.14 times 4 equals 12.56. So now I can subtract that out. And I get 30.96 minus 12.56. 18.4 is my area. All right. What questions do you have for me? I am going to absolutely have converging and diverging series. I'm going to absolutely have more area problems using the apothem. But what other questions do you want to see us go over next week and in the coming weeks? Let me know in the comments. Now, I do have a secret for you. Dr. A is going to tell you about this special code that you can use to get 35% off of your exams. But if you head to our website, you're actually going to see that there's a better code on our website. I'm not going to give it to you. I'm going to make you work for it. But if you go to our website, thelearningliaisons.com, you will see a better code that we are only running for this month than the one he is about to share. So check out our website. I'll see you next week. And I will I will keep an eye on the comments so that I can add in any other information that you want into the upcoming weeks. Thank you guys so much for coming, and I will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.